Hey there, Sabre Power people. Welcome to another episode of Think. Hey, before we get started, I wanted to send out a thank you to my new friends in Baton Rouge at the Sabre Power Services office. Thanks, Joy, for inviting me over to spend some time with Chris, Chance, Adam, James, and Cody. So thank you guys for sitting around the table and talking technical stuff with me. Had a great time. Okay, let's start. Okay, so here's the first question that I sent out. This motor on feeder F2 blows up and causes a 50 device to trip. Which breakers will open? Well, if you said F2, you are correct. So, what type of trip occurred? Well, to know that, we need to know a little bit about the language of electrical systems design. You know, over the past few years, well, actually the past several years now, we have learned the language without even trying to. The language of text. We are inundated every day with text messages from friends and family, coworkers, and they use acronyms and little symbols. And you know what? We know what every one of these mean. Like GTG, gotta go, or WTG, way to go. And what about LOL? Laughing out loud? I mean, really, when is the last time you typed LOL and you were actually laughing out loud? And rolling on the floor laughing? Seriously? In our business, we have a language we have to learn too, the one that I mentioned earlier about electrical design. It also uses acronyms. It uses numbers, letters, and symbols. And as needed technicians, it's a language we must learn.
Be a very off-color parody of former VP Nixon.
Seeing as how the VP is such a VIP, then we keep the PC on the QT because the leaks of the VC can end up in MIA and then we all be put on KP.
In the design of electrical power systems, the standard device numbers are found in the IEEE standard C37.2. It's the standard for electrical power system device function numbers, acronyms, and contact designations. This standard will identify each protective device in an electrical system, like the 27. The 27 is an undervoltage relay. We need to know this language so we know what kind of tests to run on certain relays and what kind of commissioning we need to check out on the relays. And our customers expect us to know more about their system really than they do, and so we must learn how to speak this language. Protective relays are commonly referred to by the standard device numbers. For example, a 50 device refers to an instantaneous overcurrent relay like the one you see here. Now, an instantaneous unit is a relay having no intentional time delay. It's not really quick or really fast. You will see this on a NETA exam, and they expect you to pick the answer that says no intentional time delay. A suffix letter or number may be used with the device number. For example, the G suffix can denote a ground, so a 51G would be a timed overcurrent ground relay, like the one you see here. Now the G can also be used to stand for generator, so an 87G is a generator differential relay. An 87T is a transformer differential relay. Suffix numbers are used to distinguish multiples of the same type of device in the same substation, such as the 87T1. Well, break it down. The 87 stands for differential relay. The T stands for a transformer, and the 1 identifies transformer number 1. So the 87T2 is also a differential relay, but this time it's identified for transformer number 2. So with all that in mind, which breakers will open for an 87T2? Well, let's break that down. 87, T, and 2. 87, a differential. T is a transformer, and 2 identifies a transformer as TR number 2. That's this guy right here. So here's the protection zone for TR number 2. Any breaker that can contribute to the fault of TR2 must be open. So if you picked B, C, and M2, you got it. Which breakers will open for a 63 SP-1? What type of fault occurred? And where is the fault located? Well, first, what's a 63 SP? It's a relay that looks something like this. So let's break this one down. A 63 SP1, 63 is a pressure device. SP, since this is on a transformer, stands for sudden pressure, and the 1 identifies transformer number 1. This is a sudden pressure relay. Not to be confused with this guy, which is a pressure relief device. The sudden pressure relay and the pressure relief device really do two separate things, quite different. Both dealing with pressure, but both have different functions.
So if there's a problem with the nitrogen regulation system and the gas continues to rise, at some point the ballast on the pressure relief device is going to open and vent the excess gas like this. Let me show you. Got too much gas in there, starts to go out. It's venting off and sending an annoying alarm. And there it goes. The 63 SP, the sudden pressure relay, it activates on a sudden change of pressure. That's probably going to happen if there's an explosion inside the transformer tank.
So both of these relays sit on top of the transformer tank. Can you find them? There's one. And there's the other. So which breakers will open for a 63 SP? So it's identified as a 63 SP number 1, pressure device, sudden pressure, transformer number 1. So we're looking at this protection zone right here. Remember, everything that can contribute to the fault is in the protection zone, and so those breakers will open. A, B, and M1. So what type of fault occurred? Well, a sudden increase in transformer tank pressure. And where was it located? Inside the transformer tank. So moving on, which breakers will open for an 87B-B? Break it down again. 87 is a differential relay. The B will identify that relay as a bus protection relay, and the other B identifies which bus it's going to protect. So that's going to be this bus right here on the primary side of the transformer. So therefore the protection zone will be these 3 breakers. Anything that can contribute to the fault, the breaker will open. C, B, and M2. Okay, so which of the breakers will open for an 87B-1? The 87B-1 is an 87B-1 differential bus, and on bus number 1, which is right here on the secondary side. So it's the low side bus. Here is the protection zone. Again, any breaker that can contribute to the fault will be open. In this case, it's the main breaker number 1 and the tie breaker and feeders F1 and F2.